Reducing thermal bridges. A crucial aspect of all low-energy construction methods is reducing and eliminating thermal bridges. These thermal bridges can also be referred to as cold bridges. A thermal bridge is a physical connection that allows heat to be conducted from the inside of the building to the outside of the building through materials which are poorer insulators than surrounding materials. It is important not to confuse this concept of thermal bridging with the concept of air leakage. These are completely different principles. Air leakage is where there is a break in the airtightness barrier and the air is leaking out of the building, while thermal bridging is created when the materials, which are poorer insulators than the surrounding materials, come in contact, allowing heat to be conducted through the path created. A simple example of a point thermal bridge would be a stainless steel wall tie in block cavity construction. This gives the heat a clear physical path to flow from the warm inner block leaf across the stainless steel wall tie to the cold outer block leaf. Another example of thermal bridging is the linear thermal bridge down the inner block leaf of this strip foundation detail. In the cavity wall we have the insulation tight against the inner leaf, and in the floor we have the floor insulation, but there is a very obvious gap where the two don't connect, and it's through this gap or break in the insulation that the heat is conducted down to the inner block leaf. We can clearly see with this thermal bridge that this detail would not meet the requirements of low energy construction methods such as NZEB or passive house construction. The approach taken to address and eliminate this thermal bridge down the inner leaf is to use autoclaved aerated blocks. These are the yellow blocks in the sketch and can also be called thermal blocks or lightweight insulated blocks. The foundation also uses an improved amount of insulation under the floor and at the junction of the floor and wall to minimize any further heat loss. With all the different possible construction details to satisfy low energy building methods, it is more important to understand the principle of thermal bridging rather than the nuts and bolts of all the particular details. If there is a break in insulation and there is a physical path from the inside to the outside, then a thermal bridge will occur. This will result in heat loss which will have negative effects on the building, such as energy loss, thermal discomfort, possible mold growth which could affect the health of the occupants. Taking all of this into account, it is important when designing a low energy building that sufficient time is given to detailing to ensure thermal bridges are eliminated in order to maximize the energy efficiency of the dwelling. Thanks for watching.